Okay, let us take fifth property. What happens if x of t is real and even? Okay, so till now we considered these properties separately. Now let us combine them. That is, x of t is real and even. So real means what here? X star of t should be equal to x of t, correct? So conjugation of the function should be equal to the function itself, and that should be equal to, it's even means x of t should be equal to x of minus t. So this, what will happen in frequency domain? We know that x star of t will have x star of minus j omega as the Fourier transform, and that would be equal to x of j omega, and that would be equal to x of minus j omega as the Fourier transform. Okay, x of minus t will have x of minus j omega. Now let us see what these two will give as the information. Okay, so these two will give what as information here? The conjugation of a function is equal to the function itself. That implies it should be real, correct? And what happens to these two results? X of j omega equal to x of minus j omega means that should be even. Okay, same is the case here, right? So x star of t equal to x of t means that fellow is real, and x of t is equal to x of minus t means that fellow is even. So what is it we have got? If the signal is real and even, then the Fourier transform is also real and even. Okay, so again we'll take the same example, which is x of t equal to e power minus a mod t. So what is this fellow's Fourier transform? X of j omega, which is equal to 2a divided by a square plus omega square. So clearly this fellow is real and even, correct? So this fellow is real and even. Why? If you take conjugation of x star of t, you get back x of t, and if you replace x of t with minus t, again you get x of t. So means what? The function x of t is real and even. So what happens here? What is x star of j omega? You'll get 2a by a square plus omega square, and x of minus j omega is same as x of j omega, and hence what do we say? Fourier transform is also real and even. So if the signal x of t is real and even, then the Fourier transform is also real and even. Okay, we'll take one more example. X of t equal to cos t, or cos omega not t. So what will happen? The corresponding Fourier transform is x of j omega, which is equal to pi times delta of omega plus omega naught plus delta of omega minus omega naught. So what is that you observe? You observe that our signal x of t is real, correct? If you take conjugation of x of t, you get x of t back, and if you replace t with minus t, again you get x of t back, and hence the given signal x of t equal to cos omega naught t is real and even. So similarly you can see that you will get clarity if you plot the Fourier transform. Okay, you can see in algebraic form also, but graphical representation will give us more clarity. Okay, we have Dirac deltas at plus r minus omega naught with strength pi. So clearly this fellow is even, right? If you rotate this along omega axis, you get back the function, and if you take conjugation also, you get back the function. Means what? If the signal is real and even, Fourier transform is also real and even. Okay, so in general also this is correct. Okay, so next let us talk about the sixth property, which is what happens if x of t is real and odd. Okay, x of t is real and odd. So x of t is real means x star of t should be equal to x of t, and it should be odd means x of t should be equal to minus x of minus t. Okay, minus x of minus t. So in frequency domain, what happens? I will write here. Okay, so I'll write here. So this implies in frequency domain, what will happen? We get x star of minus j omega equal to x of j omega, which is equal to minus x of minus j omega. Okay, everything is clear. Why? X star of t will have x star of minus j omega, x of t will have x of j omega, minus x of minus t will have minus x of minus j omega as the Fourier transform. But let us see what will happen if you look at these two guys. So a function's conjugation is equal to negative of that function. This implies the corresponding function should be imaginary. And what does this say? We get x of j omega to be minus x of minus j omega. That implies that function should be odd. Okay, so if the signal is real, correct, so x star of t equal to x of t means real, and x of t equal to minus x of minus t means odd. So if the signal is real and odd, then the Fourier transform would be imaginary and odd. Okay, if the signal is real and odd, then the Fourier transform is what? Imaginary and odd. Okay, we will take few examples. Let us take x of t to be signum of t, correct? So let us take x of t to be signum of t. So how does the plot of signum function look? It looks like this. So it is 1 when t is greater than 0. It is minus 1 when t is less than 0, and 0 when t equal to 0. So what will be the corresponding Fourier transform? That would be x of j omega, and we know that answer to be how much? 2 by j omega. So clearly, what is this signaler? X of t. This fellow is real, correct? All amplitudes are real, and this fellow is odd. So what will happen to the Fourier transform? So clearly the Fourier transform is imaginary, and you can see that it is odd. Okay, so why this fellow is odd? You can prove that x of minus j omega is same as minus x of j omega. Okay, you can easily prove this result. So definitely, what does it mean? If the signal is real and odd, Fourier transform would be imaginary and odd. So we'll take one more example. Let us take x of t to be sine omega naught t. Okay, so if you take x of t to be sine omega naught t, and we got the Fourier transform to be what? Pi j multiplied with delta of omega plus omega naught minus delta of omega minus omega naught. Okay, so if you try to plot the Fourier transform, how does that look? So you have a positive, I don't say positive, you have a Dirac delta at omega naught with the strength pi j, and you have another Dirac delta at omega naught with the strength minus pi j. So clearly, what does this say? The signal is real and odd, correct? We know that sine function is real and it is odd. What happens to the Fourier transform here? This function is imaginary. Why? The complete Fourier transform, we have j term, correct? So every term is multiplied with j, and hence it is imaginary, and clearly from the plot it is odd. Okay, in general also this is correct. So let's move to the next property, which is seventh one. Okay, it says what happens if x of t is imaginary and even, correct? That is the seventh property. So imaginary means x star of t should be equal to minus x of t, and this fellow is even, means that should be equal to minus x of minus t. Okay, so what will happen in frequency domain here? X star of t will have x star of minus j omega, that is equal to minus x of j omega, and that is equal to minus x of minus j omega. That would be the corresponding Fourier transforms in frequency domain. Okay, yes. So if you look at these two terms, what is that you observe? You observe that the function's conjugation is negative of that function, and hence this fellow is imaginary. And what does these two say? These two say that minus is common, so we can cancel. So we'll get x of minus j omega to be equal to x of j omega. That implies that should be even. Okay, so what does this say? It says that if x of t is imaginary, right? So x star of t equal to minus x of t means that function is imaginary. So and minus x of t equal to minus x of minus t means that implies it is even. So if the signal is imaginary and even, then the Fourier transform also would be imaginary and even. Okay, yes. So last one but not least, which is what happens if x of t is imaginary and dot. Okay, x of t is imaginary and dot. So what does it mean? It means x star of t should be equal to minus x of t, and it is odd, means minus x of t should be equal to x of minus t. So in frequency domain, what happens here? X star of t will have x star of minus j omega, which is equal to minus x of j omega, which is equal to x of minus j omega. Correct? X of minus t will have x of minus j omega, minus x of t will have minus x of j omega, and x star of t will have x star of minus j omega. So first and last terms, what does that tell us? Then a function's conjugation is the function itself, means that function should be real. And also what does second and third term says? It says that x of minus j omega equal to minus x of j omega. That means it is odd. Okay, yes. So what about time domain signal here? X star of t equal to minus x of t means that function is imaginary, and minus x of t is same as x of minus t means that function is odd. So what did we get? We got that if x of t is imaginary and odd, then the Fourier transform is also real and odd. Okay, so these 8 properties, which are conjugation properties, they are very important. Okay, so definitely we get one question from this. Okay, yes. So just as homework, so what you do, you please write down all these properties on a single page. Okay, you write down all these properties on a single page so that it would be handy for you.